Kaj Arnö from the MariaDB Foundation, and he will talk about why your AI data should be in a relational database management system. The floor is yours.
Thank you. Thank you. I have to start by taking a picture of such a full room. I'm really happy to see a big crowd here. So let me start right away by answering the question so that we can all go home. So why should vectors be stored in a standard open source relational database management system? So basically the answer is that's where the rest of your data is. It's the source data from which you create this is in a relational database very often, and the results when you want to communicate them are very well stored in a relational database management system. But also the intermediate steps, you need to audit them. Everybody's complaining about AI not really being transparent, and you're not being able to reconstruct how was a particular answer arrived at. Well, I'll walk you through the process of how we think such a vectorization is being made, and the intermediate steps need to be clear and auditable for both the developers and the users of a system. But I think the basic answer to why you want your vectors stored in a relational database management system is that it's a standard IT application nowadays. AI must not be treated as much as a special case as it has been up until now. AI apps are largely standard IT apps. We can go into more detailed answers also to the question, and that would be that you may want to combine data which is vector-based in the same query with data that is source data or result data. And then you would have a completely different way of answering the question. Of course, a good reason to store your data in a standard database management system is that so many people already know this. There's not a need to go into learning a particular new solution for what is no longer a special case. And finally, also, the tools themselves exist for standard databases. So do not reinvent wheels, just use the added niceness of the vectors on an existing wheel that you know and that are good for going around the streets with. I also asked the question related to open source specifically, not just relational database management systems. And I think the answer there is the same for why to use open source in general. Lack of vendor lock-in. That's a very, very good benefit, and it applies in this case as well. And lower total cost. It applies in this case as much as in any other case. So now we're done, and I've answered the question, so thank you. But I think you want a bit more of a detailed answer to this. So this is more or less an agenda for the presentation. I will explain what is exactly MariaDB Server, what AI functionality do we have, because not everything is there. We have there what we think belongs in a database, and nothing more and nothing less. Then what would main use cases be for MariaDB Vector? And then the detailed sort of instruction set of how to go about creating a typical use case, and I talk here about RAG, retrieval augmented generation, which I think is the main use case, which can be built a lot better using a standard open source relational database management system. And then there's a bit of a gap until number 6. So there's a lot of slides here. I hope the slides will be shared, and over half of the slides we will not walk through in detail. They are there for you as reference material, and this item 6 is more or less reading guidelines on where to download this and how to go about getting stuff done if you think this is worthy of your time. So what exactly is MariaDB Server? So how many of you use MariaDB already? Well, half-ish. So this is boring for you. You can answer email or something in the meantime. MariaDB is a mature, extended fork of MySQL. So it's almost the same as MySQL. It's a plugin compatible nearly. It's fully open source. It is performant, more performant so than MySQL, and it has added a lot of functionality on top. And I'm not now just talking about vectors. One really good example would be SQL mode Oracle, meaning that you can run Oracle apps on MariaDB. It's not like 100% compatible, but the good example we have is Development Bank of Singapore, DBS Bank, who have substituted all their internal use of Oracle with MariaDB, not by porting their applications so that they know MariaDB instead of knowing Oracle, but by ensuring that MariaDB knows Oracle, including PL/SQL stored procedures, which is the easy way of doing migration. And you can compare MariaDB, okay, I already mentioned MySQL several times, but MySQL doesn't have vectors in vector indexing in open source. You can compare it to Postgres, and of course PG Vector exists, and that's great. It has been there for a longer while than our vectors have, but it is quite a bit slower. And some people tell me this is of no. Well, we have done, I see a waving hand here. We've done some tests, and of course we welcome any contributions to saying that our test is not completely correct. But I think the major thing that where I see wavy hands when I talk to people is, does it carry any meaning that PG Vector is a plugin, whereas our vectors is part of core MariaDB? Some people says it has meaning. Others say, why care? You can just as well use a plugin. Anyway, that's a small differentiator. Of course, you should compare it to vector databases, but they are specialized, and my main argument here is there's no need for special wheels. And you could, of course, compare it to Oracle database, but I don't think they are a contender in the vector space. So what is the AI functionality that MariaDB has? So it is vector indexing and search, no more, no less. So we store and search vectors. We don't create those vectors. You decide that. You create them. You use your favorite model for doing so. It's outside MariaDB, and it can be OpenAI, it can be Llama, it can be whatever it is. So when you have vectorized your data, we then store it and we index it. We index those vectors, and now the indexing is based on hierarchical, blah, 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 small word. I keep forgetting what HNSW stands for. It's nothing about New South Wales, that much I know. And soon we will have IVF flat as well as indexing methods. And the search there is either cosine or Euclidean. And I will soon explain what I mean by soon push down. So there's a way of using indexes that we call push down. And I would argue this is exactly what you need from a standard database. So we do the nearest neighbor search. We index vectors of any data. It's not just text. It can be images, videos, sound. My testing so far has been with text, though. And we combine all of the above with existing other data. And now for push down. So push down would mean that in the where conditions, you would have mixed conditions. You would have some conditions related to non-AI data and some related to vectors. So if you want to look at similar products to some fluffy query in your region, well then in your region is an absolute criterion, a standard, a normal where criterion, whereas similar to your query is a fluffy thing, and push down would mean, and it's not yet implemented, that's sort of the forward-looking part we have here, is to combine those where you would first want to apply the absolute criteria and then do the vector stuff. So the main use cases here, this will grow, and I think the challenge here is to be very concrete in the examples, and the two super concrete examples I have is classic RAG and smarter generic search. So retrieval augmented generation, who is here familiar with RAG? The term is knowledge. No, okay, about half of you. So retrieval augmented generation is basically a specialized ChatGPT or Claude or whatnot, which gives answers not based on the data by which the model was trained, but on your data, which you then embed. So one is not supposed to use the word train for the additional knowledge that comes from your own data. That is called embedding, and you then encode using the existing large language model that you use. You take the data that you have in your, that you want to be able to be searchable using AI, and index that one. And that we can implement with high relevance, meaning exact answers and reasonable cost. And smarter generic search would be something like in online stores, you may also be interested in this product, or fluffy queries also based on embedding data. So the step here is that assuming that you have a mass of text and some free-form questions coming in, we embed the text mass in a batch run, which I said is not called training but embedding. And then you, in this, you identify the proper chunk size, and this is what makes it a standard IT application. That's the unit to index. And then you store the chunks, which is still, again, classic IT done with Java, Python, whatnot, usually Python. And then you vectorize the chunks, which is done using the favorite LLM outside MariaDB. And then item 6 here is storing it and indexing it using MariaDB, including then classical normal database fields that you can use to then later on refer to what was the exact place that you based your reasoning on. And step 2 then is the runtime part, where you answer the user's free-form question. You vectorize the same question that the users come with, and then you search the vector index for the nearest top 5, 10 nearest neighbors and get those text chunks. You concatenate them, and then you give a new query, and the only query that you give at runtime to your favorite LLM, say that please answer this question, which is the one given by the user, using only this information, which is the text that you have concatenated from the text chunks. And voila, you've provided the user with an answer to the question by the user using only your own data and at a low token cost, because you've used chunks that are not too small, not too big, and gives the entire context for the answer to be given. So this would be a sample prompt. You're tasked to answer a question using this information, and the question is such and such. And the advantage of using MariaDB, this is a bit of repetition. You can audit the intermediate steps, you can debug your chunkification and test several chunkification strategies. This is what makes it a standard IT application. You can reuse the index, you create once the index for for your basic data, and that one can be reused for making summaries or other types of data from the basic stuff that you have. Our example is our own knowledge base, the MariaDB knowledge base, so that we can give you answers on MariaDB based on only our existing documentation. So save a lot of cost by doing the searches internally, not using any kind of external service or managed service for it, and minimize the number of tokens used. So that's basically it. The rest of the slides, you're on your own. I would encourage you to look at slide 23, which is about the syntax, the create table syntax, 24, which has some surrounding Python syntax to get things going, 34 is the function syntax, and at 35 you'll find how to start kicking the tires, how to download MariaDB Vector, and slide 36 is where we brag a bit about our speed, the speed of MariaDB vectors. And there's a URL also with all the complete documentation about MariaDB Vector. So, floor is open for a number of seconds of questions.
Thank you, Kaj. I think we can get in one short question. If there's anyone, but please keep it very brief. Yes, we have the microphone.
I can do also without the microphone.
Yeah.
So, you presented from your product perspective, which is RDBMS. What about NoSQL? So did you run some tests?
What about?
NoSQL database. So like Mongo. So do you have some also benchmarks?
We don't have the benchmarks on Mongo. So our benchmarks are in the relational space. So it would have Postgres ourselves. It would have the specialized vector databases. I'm sure there might be in the NoSQL space as well something.
Okay, thanks again. We have a short 5 minute break.